Here we have a biconditional statement. Bi means two. Biconditional would simply mean bidirectional. So we denote a biconditional statement simply by using an arrow that's pointing in both directions. There is a specific name for it, I forget, for that arrow, as in going both directions. But mathematically, when I see that, my mind would go for if and only if. And the notation is I with two Fs. When we write I with two Fs, we mean to say if and only if. What does that mean? That simply means P is the antecedent, Q is the consequent, in the sense if P, then Q, P is sufficient for Q, Q is necessary for P. So that goes in one direction, but if you have if and only if, there is another direction. So we're just flipping it and writing it as Q would result in if P, then, excuse me, if Q, then P. So the forward direction is possible, the reverse direction is possible. And here, Q is sufficient for P. Q is necessary for P. My bad. P is necessary for Q. So in the first case, antecedent is P, consequent is Q. Second case, Q becomes the antecedent, P is the consequent. So there are two cases where the first one says if P, then Q. The second says if Q, then P. For us to be bidirectional or biconditional, something must go right here to combine those two. What would go there in the middle to combine those two statements? So the resulting statement is a biconditional statement. So what goes here in the middle is and. It should satisfy the first condition and the second condition for us to conclude that the statement is biconditional. Biconditional is also if and only if. Now, I can't stress this enough. Just because I write a statement that P, if and only if Q, doesn't make it true. Just because you write it, P, if and only if Q, doesn't make it true. It has to make sense. The reason why we go over this is for notational purposes. How would we interpret that statement when I write it in paper? Good. Let's see. I'm going to do a simple example. Suppose x is equal to a plus 1. That is a simple equation. And if that is my condition, and let's say if a equals 2, then x equals 3. So if someone says, oh, I have this equation, x is equal to a plus 1, then naturally, if a is 2, then x has to be 3. For x equals 3 to happen, given x is equal to a plus 1, p, which is a equals 2, is sufficient. If I plug in a equals 2, I am going to get x is equal to 3. So a equals 2 is sufficient for x is equal to 3 if I'm looking at the equation x is equal to a plus 1. Now, if x is equal to 3, and I'm using the same equation, what should a be? Well, if x is 3, if you solve for a, then a is 2. So initially I picked a equals 2, x is 3. If x is 3, then a is naturally 2. So I can go in the forward direction. I can go back in the reverse direction. Both of them works. So if B, then Q. If Q, then P. And provided I have that equation. So in this case, if I call A equals 2 as P, x is equal to 3 as Q, I can write this notation or write this scenario as P if and only if Q. So let's say I'm writing some sort of an article and I'm trying to make a point, trying to explain some logic that I have, and I say P if and only if Q. For the reader is going to interpret it as if P, then Q, if Q, then P, both of them are true. Now, would the reader agree with me? Maybe, maybe not. But in this case, the reader will agree with me because I'm talking about that particular equation. That equation will satisfy what I wrote right here. So when we write a biconditional statement, the if then has to work in both directions. One of the important things that we've got to keep in mind is the use of parentheses. I always tell my students, use parentheses. It doesn't matter whether it's, absolutely required or not. Putting parentheses always helps in algebraic calculations. But when it comes to logic, putting parentheses will actually make a huge difference in interpretation. Take this case. Negate P or Q. Negate P or Q entirely. So in the first case, we are simply negating P. However, in the second case, we are negating P or Q. So they're not the same. So we've got to be careful when we use negation. People would always misinterpret if you don't provide or if you don't use parentheses.